We saw how to divide one number by another. For example, 32 into 864 equals 27. And we also saw that this rule is related to multiplication. In fact, 32 times 27 equals 864. In this case, we say that 32 and 27 are factors of 864. Factoring is when you take some number and divide it into a series of other numbers called factors. The process of prime factorization reduces each of the found factors into a series of prime numbers, those that are divisible only by themselves and 1. For example, 2, 3, 5, and 7. Once the student understands division, it becomes clear that the divisor and the quotient are factors of the dividend. This works only in the cases of whole numbers where the problem does not result in a remainder. This is an example of a factoring tree that can be made. You start with your original number, in this case 864, you divide it into a pair of its factors, 32 and 27, and again, and again. At each row of the factoring tree, multiplying the numbers together should equal the original number. This only works in the cases of whole numbers that do not result in a remainder. Once the first set of factors has been found, each of those can be reduced into a pair of its factors, and again until every number in the bottom row is prime. At this point, the process ends, and the prime factors have been found. But how do you know this will eventually end? Once the first set of factors has been found, each of those can be reduced into a pair of its factors, and again until every number in the bottom row is prime. At this point, all the prime factors have been found, and the process ends. Though they may be arranged differently and have different numbers in the middle layers of the tree, the original number and the set of prime numbers at the bottom should be the same for each student. And this idea follows the fundamental theorem of arithmetic, by which every number has its own unique set of prime factors. The method of prime factorization is very useful when dealing with larger division problems, for example, 48 into 864. Each number can be reduced into its prime factorization and set up as a fraction of its factors. And by using the identity property, whereby each number divided by itself is 1, you can cross out many of the numbers. For example, 2, 2, 2, 2, 2, and then 3, and 3. So you get 1 over 2 times 3 times 3, or 1 over 18.